To begin with, my program will initialize a RoSB node using the solver class. In this method, the node will be subscribed to the laser scan, image and odometry topics. These three features will allow the bot to detect its position in relation to the maze using the odometry topic, and its distance from the walls using a left, right and front laser. As you saw just then, the bot detected the red square on the floor. This causes the bot to turn 180 degrees as the red squares represent the wrong way. It will also use the image sensor and an OpenCV bridge to detect colors and to provide the user with a point of view perspective of what the robot sees. As you can see here, the program detects the blue square on the wall. The green circle represents the centroid of all the blue areas visible from the image topic. This centroid is then used to calculate an error value which is used to adjust the direction of the robot continuously as it moves. Once the robot has got close enough to the blue square, the sensor is turned off to allow the robot to carry on through the maze without getting stuck driving into the blue square. To prevent the robot from driving into walls, the laser scanner is used to detect whether the bot getting too close to a wall. If it is, the robot will stop, and then turn 45 degrees in whichever direction has the most space to move. As well as this, the left and right lasers are used to calculate an error value to keep the robot as evenly distanced between the walls on either side of it as possible. It works by continuously adjusting the angular velocity of the bot as it is moving forward to turn it slightly away from its closest side. I think this makes a big improvement on how the bot traverses through the maze as it makes smoother turns. For example, in this zigzag section, it is able to go through the middle instead of up and down into each corner section. This next part is a good example of the bot getting stuck when it is surrounded by three walls. My solution was to use the odometry topic to track if the bot is moving anywhere. I had to do it this way as even if the bot is stuck driving into a wall, its velocity according to itself is that it's still moving, so I had to be able to get its position in relation to the maze. While the X position of the bot stays the same for a certain amount of time, a counter is counting up, and if that gets too high, the bot will turn 180 degrees to allow it to find another route. When green is visible, in the same way as the blue squares, the bot will move towards it. However, when it reaches the green, the bot will stop.